Hello and good afternoon, CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course from Cisco Networking Academy, and this afternoon's video tutorial is going to be our first look at BGP for IPv6. We're going to be doing that through the lens of the Cisco Learning Labs curriculum that we have as part of our course, which is Discovery Activity number 24, which is named actually BGP for IPv6. So this is the topology that we're going to be dealing with here, and it looks like we may be doing either dual stack or 6/4 or maybe even 4/6, right? Because remember, we can, with the multi-protocol extensions to BGP, actually do IPv4 over IPv6, or excuse me, a more typical scenario would be you're trying to add in some IPv6, but you don't want to do dual stack, and then we'd be looking at doing IPv6 over IPv4, that existing IPv4 configuration that we have. So let's go ahead and take a look at router 1 here, and we're already in privilege exec, so let's just say show run section BGP. And so here's the BGP configuration section for router 1. And as you can see, we've got the address family IPv4 Unicast, and we've got our IPv4 network and neighbor statements here, and we're activating this neighbor. And then we've also got this IPv6 stanza here. Now what's interesting is in this v6 stanza, we have the v6 network statement, but take a look here. We have two neighbor statements, one to activate the neighbor adjacency, and the other one setting the next hop, doing a route map, setting the next hop excuse me, in the outbound direction. But what do you notice about the IP addresses that we're seeing as for the neighbor statements under the address family for IPv6? These are IPv4 address statements, and so what we're IPv4. So what we're doing is we're actually doing IPv6, right? This is v6 over v4. And this is an alternative way to communicate and distribute the IPv6 NLRI that we're interested in advertising. Specifically, it would be this network statement here. And again, the 6/4 scenario is most commonly seen when you've got an IPv4 environment already, and you want to start to roll IPv6 out, but you don't want to do dual stack. And so what you can do is you can do v6, or so you just hear it sometimes as 6/4, right? And what that means is IPv6 BGP NLRI, that network layer reachability information, the prefix and the prefix length in update messages being sent over IPv4. And that picture that I had I've shown a picture before. Boy, an art is definitely not my strong suit. So if this was a bus, we'll say, right? And you've seen me with the transport, right? What is the transport? Well, the transport is, this is the IPv4 trucking company, right? And back here in the back of the truck, that IPv4 trucking company can take as passenger protocols, right? It can communicate IPv4 or carry IPv4 information. It can carry IPv6 information, right? It can carry VPN v4 information. And so again, just to show you that the transport, right, or the bus is the transport protocol, in this case IPv4, and we can see that here with the neighbor statements. And the passenger protocols are the protocols that are being communicated or transported via the IPv4 transport protocol, can be v4, v6, VPN v4, right? So let's go ahead and clear the slate here and get back down into our window. If I was to say show IPv4, or show BGP IPv4, so now we're going to start to take a look at the new commands, right? And when I say the new commands, these are sort of the address family specific commands. So we say show BGP IPv4 Unicast, and what is that the same command as? Exactly, show IP BGP. So, but again, now that we're using the address families, if I wanted to see the IPv6 information, what if I said show IPv6 BGP? right? So I don't see anything, right? If I said show IPv6 and did a question mark, you can see that BGP isn't even an option for me here. And so then that begs the question, how do I get to that IPv6 address family information? Well, you're going to have to come out and say show, and then what would the command be? BGP IPv6 Unicast, right? And there we go. That's what the v6 BGP local rib looks like. And that's why you want to start to get into the habit of saying show BGP IPv4 Unicast. Now, it's obviously a little more work than show IPBGP, but to get yourself into that sort of habit of specifying the address family, especially if you're working in an environment where you have both IPv4 and IPv6. And a lot of the other commands, it's the same thing. Show BGP IPv4. If I did a question mark, you can see, well, say Unicast, and then the question mark, you can see, I can say neighbors, I can say summary, I can say peer group. So again, you can display, we can say version, right? Oops, so we go version. Let's go with neighbors. And so then there's the neighbor command, right? We can see external link for the neighbor 172.16.12.2. So it's show BGP, the address family identifier, which is IPv4 or IPv6, and then the what they call the SAFI, the subsequent address family identifier, which is going to be unicast or multicast. We saw it appear earlier when I ran it a little too soon, right? MVPN. So the two that we'll deal with, or actually we're probably only going to be dealing with unicast, but know that there were other options for multicast, MVPN, and MDT. So the command syntax changes a little bit because now we're forced to deal with the address families. So let's jump onto router 2 and let's do the same thing here. Let's go ahead and say show run section BGP. And you can see here on router 2, we've got the two neighbor statements here for 65,100 and 65,000. But again, no IPv6 information configured here. The IPv6 information was out here on router 1. So router 2 doesn't have any IPv6 BGP configuration work set up yet. And then the same thing, we'll take a look at router 3 here real quick, and then just a show run section BGP. And again, we can see that router 3, which only has that IBGP peering with router 2, has a pretty limited BGP configuration section. All right, so from router 3, if I were to try to ping 192.168.11.1 and source that from my Loopback 1 IP, we've got reachability. But what is that 192.168.11.1? It's right here. It's the Loopback 1 address on router 1. So from router 3, I have reachability out here to the loopback that's on router 1. And why is that? If I were to say show IP route BGP, you can see that I've got that BGP learned route, because as an IBGP speaker, right, I can pass on eBGP learned routing information to IBGP peers. But what I cannot do is pass on IBGP learned information to IBGP peers. Remember, that is the IBGP default loop prevention mechanism, is that IBGP peers, if they learn NLRI from another IBGP peer, they cannot advertise that information to other IBGP peers, right? Because it would cause loops. All right, so I'm on step 4 if you're following along. We've looked at the config so far. We've seen that we're definitely doing 6/4. At least we're set up for that over on router 1. So now we're going to jump down to router number 2, and we're going to set up the exchange of the IPv6 information with router 1, because as you look at this here, you can see that we don't have any IPv6 information configured. So let's go from privilege exec to global config. We're going to say router BGP 65,000. And again, there's not much going on here. So let's say address family IPv6 Unicast. Now, remember, it's 6/4. So under the v6 address family, our neighbor statement is going to be the IPv4 address, 172.16.12.1, and we're going to say activate. Now, as you can see, it came up right away. And now let me originate the NLRI 2001:DB8:0:22:/64. Now we're going to take a look at the config section. Do show run section BGP. Now take a look at that configuration section. It looks much more like router 1's, and there's been some significant changes. We never said address family IPv4, but iOS and the BGP code is smart enough to know that if we go into the address family for IPv6, it's going to create for us these two configuration sections, right? The address family for IPv4 and the address family for IPv6. Now, something that typically gets done, and let me exit up one level here. Something that typically gets done, now not part of the lab, but definitely something we want to address, is that you'll see no BGP default IPv4 unicast. And I'll hit enter. And let's say do show run section BGP to see if anything changed. So other than the fact that this command now shows up in here, right, nothing has really changed. And what does this command do? What this command says is that by default, if I declare an IPv4 neighbor, I have to manually go in and activate it, right? Whereas if I don't do that, it will automatically drop this activate statement in here for me. So you'll typically see that this will be done to force the network administrator or engineer to actually specifically activate that family. And it's not a bad common practice to do that to make sure that you don't mistakenly have peerings that are coming up that maybe you don't want to come up right after you enter that neighbor command. Okay, so we've taken a look at that there. Now let's go ahead and on router 1, let's see what router 1 sees from its perspective. If I were to say show BGP IPv6 Unicast summary, you can see that we now have the peering, and we've got one prefix received, and the peerings with 172.16.12.2, which is router 2. So the same thing, show BGP IPv6 Unicast neighbors, and there we go. We've got an external peering set up where we're communicating v6 information again, and it's very important here to take notice. We're saying show BGP IPv6 Unicast neighbor, but the neighbor is an IPv4 address because again, this is just simply our way of being able to send that v6 NLRI, right, that single network statement that we have for the 2001 DB8 over the transport that already exists, which is IPv4. But now we're about to see the challenge here. So we'll say quit, and I'll say show BGP, show BGP IPv6. And again, if you don't put, it says Unicast in the lab, you'll see that. And you see how it says note, that command is deprecated, please use Unicast. So you can get away without typing Unicast in all the time. Could be iOS dependent, but I think for most of the recent releases, you can still say show BGP and then the AFI, which is either IPv4 or IPv6 in our case, and then just hit enter, and you're going to get that information back. So if I were to say show BGP IPv4, it assumes, show BGP IPv4 summary. And is it going to force me to put Unicast in there? So for v4, it's actually going to force us to do Unicast. For v6, we do not have to put Unicast. That's interesting. I did not know that. In fact, let's take a quick look here. And let's see on a router, and where is it? So this router is running 15.6 code here. So if I were to do that same thing, let's check and see if on 15.6, which is, this is the most recent code that's out there as part of the T-train for the 1941 ISRG2, if I were to say show BGP IPv4 and do a question mark, yeah. So for IPv4, it's going to force me to say Unicast. What about IPv6? Yeah, it looks like it's changed it here, right? So you're not going to be able, well, BGP is not active, but you'll notice there's no carriage return. Usually it says, bracket, CR, bracket, if you can hit enter. It looks like maybe with the most recent release anyway, looking at that you're going to have to type that in. So always good to know. Typically, I'm able to get away with it on some of the older releases. You don't have to put in that unicast argument. So, but what do we see? Yeah, so we sort of see this IPv4 embedded address, or IPv4 address embedded in this IPv6 address, and it just so happens that that's in the next hop column. Well, that's a problem, right? Because that next hop doesn't actually exist. So let's see. Can I ping, if I were to ping 2001:0:0:22:, and is it 1? Let's check it out. 2001:0:0:22:1. So it's right here. It's a loopback address right off of router 2. I'm directly connected. Well, not directly connected, but I'm connected to router 2 here, and I can't even ping that address. Because again, this next hop, you'll notice that it's valid, but it's not best. And it's not best because it can't resolve that next hop. That next hop doesn't exist anywhere. Because again, we've got that IPv4 address, and that's what the peering is formed over. So it basically sort of throws in this quad Fs and then piggybacks the last 32 bits as the actual IPv4 address used in the neighbor statement. But that doesn't exist as an IPv6 address. And this is where we get into the scenario where you're going to have to create a route map in order to facilitate that reachability. And so that's what it says. When you compare the BGP states between R1 and R2, you'll find out that the route that's received from R1 is marked as best, but that's only because it has a valid next hop. So if I was on router 2 and I said do show BGP IPv6 without the unicast, you can see this 22 network here, this 11 network here, which sits out behind, right? It's this network here, loopback 1. On router 1, we've got reachability to that. So 2001 DB8, DB8:0:11:1, we've got reachability because the next hop actually exists. But the only reason that we know about that next hop is because in the outbound direction on R1 show run section route map, we created a route map that manually sets the next hop, and then we apply that route map in the outbound direction. So what are we doing? Well, let's take a look at the map and let's talk through this. So this is what's happening with that route map, right? And this is going to be problematic when you do 6/4, because we're establishing peerings with our underlying transport of IPv4 using IPv4 addresses, okay? And this is going to be a problem because when we go into the address family for IPv6 and I drop those neighbor statements in there, the iOS code looks at that and says, okay, well, I don't have an IPv6 next hop address, so I'll just put that quad Fs in there and then piggyback whatever, 172.whatever IPv4 address that he used in the neighbor peering. So what happens is, right now here on router 1, the reason we have reachability to that IPv6 prefix is because we created a route map in the outbound direction, right? So think about this. We have a route map applied to the neighbor statement for router 2 that says, for all NLRI in the IPv6 address family, for all NLRI that I originate and that I send over here to router 2, you're going to set the next hop, but specifically I'm setting the next hop to a valid IPv6 address. So again, we need to have a valid IPv6 address, and you can see we've got ::1 there and ::2 here. So, and you're setting, so to take a step back, so router 1 declares a route map, And in that route map, it applies it to the neighbor statement with R2, and it says that R1, anything R1 sends from the IPv6 address family, any NLRI it's originated, that it is going to set that mandatory well-known attribute of NextHop to its local interface. Because then when that NLRI gets here to router 2 says, oh yeah, well, it just so happens I see that as being a directly connected network because I know exactly where that IPv6 NextHop is. And therefore, we're able to send that IPv6 NLRI over an IPv4 peering, even though it's IPv6 NLRI, and that is 6/4. And again, remember, this is in contrast to doing this as dual stack, right? And so what does it kind of buy us? Well, we've only got a single IPv4 BGP session spun up. Now, this was probably, again, it's probably a good use case if you're trying to incrementally roll v6 out, right? But if, with today's hardware especially, I would think that dual stack is probably the easiest way to do it, and really from a CPU and an overhead perspective, which is what this kind of tries to avoid, that you don't have two separate BGP processes running, one for v4 and one for v6. Everything's being done with v4. But again, I mean, with today's horsepower in the routers that are being sold today, it's kind of a moot point. So I would personally always use dual stack when I'm rolling things out, just to make it easier to keep track of. Because again, this NextHop challenge that we have, if you're doing v6 over v4 throughout your environment, guess what? You're going to be creating route maps on every peering along the way so that the next hops actually make sense and they're not these v4 addresses embedded into a v6 address that's basically that quad Fs. All right, so back onto router 2 here. So now that we've seen that, yes, this is best and valid because we can resolve that next hop here on router 1. Yeah, we received the 22, right? But look, not good. No good valid next hop. So let's sort that out. Remember, we've got to fix it on the the originator's side. I was going to say the advertiser side, but more proper to say the originator's side of the house. So let's go ahead and do that. So we're going to say route map, and I'm just going to call it next hop. I'm going to hit enter. Remember, when you hit enter there, is it permit or deny, and what is the default sequence number? Exactly, it's permit 10. So the route map's very simple. Everything, because we're going to be applying this under the IPv6 address family to the neighbor statement for router 1. And what we're going to say is, I want to set the IPv6 next hop to my, whoops, not 2011, 2001:DB8 to my :0:12:2 to my IPv6 address that's on that interface that I have that goes to router 1. So basically all the IPv6 NLRI that router 2 originates and sends on to router 1, the next hop will be changed to 2001:DB8 0:12:2. It will no longer be this quad Fs 172.16.12.2. Doesn't make any sense, right? All right, so once we've got and again, very simple to do this, setting this route map up. Now we just go into router BGP 65,000. And let's say do show run section BGP. Let's get a quick look at what we've got here. So again, we're going to go into the address family IPv6, and if I hit enter, it puts me into Unicast. So again, you check and see. You should get an error if it's going to force you to say Unicast, but by default, the address family is going to be Unicast. So we say address family IPv6 Unicast, and then on the neighbor statement, over to the 172.16, is it 2012? 12.1. We're going to apply that route map, which is just next hop, and in which direction? Do I apply it to NLRI that I'm learning from router 1, changing the next hop to me? No. I applied in the outbound direction for all IPv6 NLRI that I am advertising to router 1. I am setting the next hop to my that interface that goes to router 1, which you could say would be the update source interface, I'm setting the next hop to that IPv6 address, right? And again, when you think about it, if I have to put IPv6 addresses on all the interfaces between the peerings, why would you not just run dual stack, right? It's just as easy, it's easier to run dual stack because you're having to put IPv6 addresses out there anyway. All right, so let's go over to router 1 and let's see, did it take, or are we going to have to do some sort of a reset here? So let's say show IPv6. All right, are we good? We are golden. And there is that next hop address to which it sees itself as show IPv6 route. Should be seen as directly connected. DB8012, where's that at? Yep, sees it as being directly connected, right? Because it's over that WAN transport, Metro E or whatever the case may be, that we've got that connection. So now when I try to ping to the 2001 DB8:0:22:1, now we end up with success because, again, we have the routing information that's required in order to make that happen. Okay, so now that was from router 1, and you'll notice we didn't even have to source it off of the loopback. So now on step 9, there's quite a bit going on here in step 9. So it says configure an iBGP session between router 2 and router 3, loopback 0 IPv6 addresses. Use IPv6 transport to exchange v6 networks. And so what is that? So if we're already doing v4 over v4, and let's bring up the drawing here to make sure that we're clear. So we're already doing v4 over v4 in here, right? So we've already got v4 over v4 between this iBGP peers here. So now we just did v6 over v4. Whoops, left out the v here, right, between these two guys, these eBGP peers. So now we're going to do dual stack. Again, these activities, the Learning Lab activities, are just absolutely fantastic. So we're going to do v6 over v6. So we got to see v4 over v4. We did v6 over v4. Now we're going to do v6 over v6. So in other words, these guys will be dual stacking it, right? Well, at least with the iBGP peering, it'll be dual stacking it. Over here, it's still v6 over v4. But between these iBGP peers, we'll be dual stacking it. All right. So let's jump back. Let's get on to router 2 here. And I think we are already in that address family. We're already do show run section BGP. Okay. So now let's go ahead and drop into the, well, actually, since we're doing the dual stack, we'll say neighbor 2001 DB8:0:3:3:3, and the remote AS is 65,000, right? So that's the v6 address of router 3. And remember, it's an iBGP peering, but that is the v6 address of what? Is that of the physical interface, which I'm directly connected to right here? No. Remember, that is the loopback, where's that? Right here, the loopback 0 interface. So if I'm setting the peerings up, what else do I need? Just like v4, I need to say update source loopback 0. Yeah? Okay, good. So now we'll drop into address family IPv6. Don't have to put Unicast because that's the default. And we're going to say, pull the neighbor statement back up. Now remember, I have to activate it, right? You have to manually activate that session. And since it's router 2, given this topology here, what is going to be something very, very important that we need to set on router 2? So when it advertises eBGP learned NLRI over to router 3 needs to know what about that NLRI? Exactly. It needs to know a next hop it can get to. So on router 2, since that has the eBGP peer, we're going to say NextHop Self. Now, it's interesting, as part of the activity, they actually have you set the NextHop Self on router 3, but we'll talk about that as to whether or not that's actually needed, because we don't need to change the next hop there. So we'll give a quick write mem here. Save that off, come over to router 3, Get into global config, router BGP 65000, neighbor 2001 DB8. Is it 0, 0 colon 2 colon 2. The remote AS is 65,000, right? It's an IBGP relationship. We know that's a loopback address, so the update source is going to be loopback 0. Now, we've got do show run section BGP. So we've got this neighbor statement here, and again, everything here on this router is still IPv4, right? So we've added these statements in, but we haven't said address family IPv6 Unicast. Now, remember what this looks like right now, and watch what's about to happen. Now take a look at that. We get the address family IPv4, and as soon as I drop in the neighbor statements here for the activate, the 2001 DB8 0 2 2 activate, and then we'll set NextHop. Well, actually, we don't need to set NextHop Self, and we'll talk about that. They show you to set that, but it doesn't make any sense. And there we go. We've got the adjacency is up. So let's see. Do show BGP IPv6, right? And so you can see I'm learning, right, from an IBGP peer. I learned this 22 network, and I learned about the 11 network. Now, which one? It's the 11 network, right? Yeah, 2001 DB8 011 is out here on router 1. So, but router 3 sees what as the next hop? Exactly. It sees that update source address, right? That loopback address of router 2. Saying, hey, the next hop, I am your next hop. Come to router 2. I can get you to where you need to go. And that's important, because if we don't have that in there, so if I were to go back and yank, actually on router 3, so if I were to come over here to router 2 and yank that out, right, let's break it and see what it looks like. Router BGP 65,000, address family IPv6 Unicast, and do show run section BGP. So if I were to come down here and say, no, neighbor 2001 DB8 0 3 3, NextHop Self, and then say do clear IPBGP star soft, and then come back over here, let's see what it looks like now. What do you think the next hop value will be now? Do show BGP IPv6. Again, we don't have to say Unicast here. Aha, well that's interesting, because now it's not 2 2, it's 12 1. Keep in mind, right? There is that 12 : right? Here's this 12 : /64, and that is the outgoing interface by default, right? That is going to be the next hop value that router 2 is going to preserve and simply give to router 3, unless we tell router 2, hey, you have to change the next hop to yourself. So let's drop that back in here. Let's say Control A. So we'll get it correctly set up, and then we'll do a quick clear. All right, now we'll come back over to router 3. You can see it loves to tell me that that is a deprecated command, that I should say Unicast at the end. And so there we go. So do show run section BGP. I think that is it. We've got the activate. Yeah, so the final thing that they had was the NextHop Self. But is that required? Is it required on router 3 to set the next hop to self? Well, in this scenario, it's not, because 3 has no eBGP peerings on which it's going to maintain. Right now, this would be different if it looked like this, and we talked about this on on Monday evening. We talked about this, where if do a circle out here, and this is AS whatever, AS 99. Right, and we've got a router out here, router 9. And this is an eBGP peering here. If 9 is sending in NLRI to 3, then setting the next hop self makes sense, right? That's going to end up making sense on the neighbor statement to router 2. Because 3 would not pass on, doesn't want to pass on the outgoing interface here on router 9, which 2 might not know anything about, and probably doesn't. So then it would make sense to set NextHop Self here on router 3. if it had an eBGP peer, right? And let me ask you this. So let's say router 3, let's say there's a router 4 here that's in 65,000. Does it need to set NextHop Self on the neighbor statement with router 2 so that it changes to the NextHop of router 4 who's an iBGP peer? Think about that. No. Why not? Why does it not need to set NextHop Self? Because if this is an iBGP peer, which we said that it was, it's in this AS65000, if that's an iBGP peer and it sends an iBGP or an NLRI update to this iBGP peer router 3, is router 3 going to send an iBGP learned update to an iBGP peer? No. Which is why you don't see NextHop Self being set between iBGP peers if there's no eBGP peering. Again, the NextHop preservation that exists here when this router 9 sends NLRI down here to router 3, it's going to preserve the NextHop value that the NLRI showed up with by default. We have to override that and say NextHop Self so that when the eBGP learned NLRI is then communicated over to router 2, who's an iBGP peer, he sees router 3 as the next hop, not this address out here, which he probably doesn't know how to get to. So again, I know we talked about it in class on Monday night, but it's good to cover it again and again and again, because this is definitely one of the things that trips up a lot of learners. So the final thing that they've got us doing here is on router 3, basically a do show BGP IPv6 Unicast summary. See if we can get away with this. All right, we got away with that. Still deprecated. So what they're wanting us to do is to say Unicast, to jam Unicast in here. Okay. And so there it is, right? And you can see we've received two prefixes, that 11 and that 22 network that we're picking up from router 2, as well as that router 1 out there in AS65100, I believe. Yeah, 65,100. Okay. Well, this is going to wrap up this discovery activity. Again, we talked about a lot here. Remember, when we're talking about V6 over V4, V6 over V4, which we talked about here, one of the use cases for this is you don't want to do dual stack, that you're trying to keep a single BGP process, just a V4 BGP process, over which, right, the V4 process here is the transport, right? This is your truck. And inside the truck, I've got some passengers, passenger protocols. I can carry V4, I can carry V6, and in this case, we're carrying V6. Down here, we did dual stack, where we did 4 over 4, and we did 6 over 6, where we didn't get into having to set the next hop. And again, that's one of the significant drawbacks to 6 over 4, is that you're going to have to go through and you're going to have to create a route map on all the peerings, right? If you've got a whole bunch of peerings running around in your environment and you're trying to do 6 over 4, you're going to have to go around and set those next hops via route maps to legitimate V6 addresses. And if you've already configured the V6 address, why not just run dual stack? Right? So something to think about. But again, clearly use cases for both. You may want to get choices here, and that's the one thing that I love about the networking field, is there's always more than one way to do it. Coming up with Unix, it was the same thing, right? There's always more than one way to accomplish a task. All right, well, that wraps up this video tutorial on discovery number 24, where we did BGP for IPv6. Enjoy the rest of your weekend, and I will see you on Monday night.